hello again, and welcome to Astronomy Toronto. I'm your host. My name is Randy Attwood, and I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada. Well, Astronomy Toronto is Toronto's astronomical monthly news magazine, seen here on Rogers the first Thursday of every month at 8 o'clock. Well, the 1984 August edition of Astronomy Toronto is the summer skies. There are a lot of weekend cottagers in the city these days, and during the weekends, when you head up to your cottage, far away from the city lights, many of you might become weekend amateur astronomers, wondering, what am I looking at? What am I seeing when I look up at the dark summer sky, the Milky Way, the planets, and the moon? Well, that's what we're going to talk about for the next 30 minutes, the summer sky. Take a look at the things that we can see. And as my guest for the, I don't know how many times, Ian, you're just a regular on Astronomy Toronto, my good friend Ian McGregor, who is the producer at the McLaughlin Planetarium. He writes all the student shows for the planetarium. Thanks again, Ian, for coming by.
Good to be here, Randy.
Well, let's start out, Ian. What are some of the highlights this summer in the sky?
There's lots of exciting things happening this summer. Of course, we've got our spectacular skies that we associate with August. It's a good time of the year to be observing. We can get out in the evening and actually look up at the sky. It's not too cold. We don't have to worry about winter coats. Of course, we've got a whole variety of phenomena that take place. The moon's around. We have 3 planets, Mars, Jupiter, and Saturn, that are visible. We have a nice meteor shower coming up on August 12th. Occasionally, we can see some aurora, meteors, satellites. A whole variety of phenomena are in our sky this summer.
Well, the first thing, once you begin to learn about the summer sky, first thing you should look at is a few constellations. How do we find our way around the sky, Ian? Where do we start?
I think most people who are beginners are a little bit bewildered by the sky. You look up into the sky and it's sort of filled with stars, and where do I start? How do I ever figure out where these things are? And so perhaps the best thing to start off with is a constellation or star picture that we all know. We've probably all seen at one time or the other. And this is the star picture that we call the Big Dipper. Now, if we look at our first slide, we can see the Big Dipper, and it's a part of a much larger constellation that's called Ursa Major, the Great Bear. And in this picture, you can see the 7 stars of the Big Dipper make up this much larger picture of the Great Bear. We can use the Big Dipper to find a very important star known as the North Star, or Polaris. And in the second slide, we can see that if we use the 2 stars at the end of the bowl of the Big Dipper, what are known as the pointers, and draw a line through them, and extend that line about 5 times the distance between those 2 pointer stars, you end up finding the star known as Polaris. Now, Polaris is not the brightest star in the sky. Often people think it is, but it is one of the 50 brightest stars in the sky.
And which direction are we looking at?
Okay, well, we found the Big Dipper, and we're basically looking, I guess over to the
due north.
Due north, I guess. Yeah. We're trying to look to find Polaris.
Okay.
And then the line from Polaris, North Star, down to the horizon gives us the direction north. So that means we now have got 1 bright star and 7 stars that we can work with. Now we now know north. We now know one of our well-known star pictures. We can now go along and start to look for some other interesting objects that are in the sky.
Okay, I think we have in the next slide, Ian, a photo of a photograph that anyone can really take, and that is of star trails. This photo, if we can get the slide up, is pointed right at Polaris, isn't it? Tell me about this picture.
This is a picture showing what we call star trails. The bright star more or less in the center of the picture is Polaris, the North Star. And what is happening is a camera has been set up on a tripod, and the lens the shutter's been opened, and the film has been exposed for a period of time. And what we end up is with star trails. And this is just reflecting the fact that the Earth is rotating on its axis. If we were able to set the camera and expose it for a 24-hour period, those star trails would end up being circles. I can perhaps bring out a simple piece of equipment for taking constellation pictures or things like star trails. This is just an ordinary tripod, an ordinary camera tripod. And I have a 35mm single-lens reflex camera mounted on this tripod. In order to take some pictures, I put some fast film in here, perhaps maybe 200 ASA film, 400 ASA film. I have a cable release, and this means that this enables me to hold the shutter open for 20 seconds, a minute, 2 hours, however long I want to go. So I'm outside, and I take the lens cap off, and then I go ahead and I open up the shutter,
Mhm.
and to get, say, a constellation picture, I hold it open for maybe 25 seconds. To get some star trails, I might hold it open for maybe an hour, 2 hours to get some nice star trails.
And the thing to remember, of course, is wide open, focus to infinity.
Camera's wide open, focuses to infinity.
No flashes allowed.
No flashes allowed, certainly no flash, and you have your camera on, say, in the bulb setting.
Right.
And then so with your cable release, you're holding your shutter open for however long that you want for your exposure.
And of course, another thing to remember with star trails too is that if you're in the city, anything longer than 30 seconds will be washed out. But
Yeah,
if you're up
just
in the country, even anything longer than about an hour or so, you begin to get some background lights, or what we call sky fog.
Sky fog.
So anything longer than an hour is real, unless you're in a very, very dark sky.
Really dark sky. We haven't got too many sites like that in Ontario these days.
Okay, Ian, how about some other constellations? I think we have some more pictures of...
Well, we've already looked towards the north. We found the Big Dipper and the North Star. Now, if we look towards the south, we end up getting some other constellations which are of interest. In our next slide, we have a diagram which is showing some of the southern constellations. We have the long, sort of sprawling constellation of Scorpius. We're looking pretty well directly towards the south, and Scorpius has the bright star Antares in it. And then to the east of Scorpius, we have the constellation of Sagittarius, the Archer. Now, most amateurs don't have a hard time imagining an archer there, but if you look at that part of the sky, you can usually spot a teapot. And so we often refer to this as the teapot.
And it's very, very close to the horizon. You need a very,
Very
flat
low in the
southern
sky.
horizon.
And with good skies, it's very noticeable. Now, if you go to the next slide, we see a picture that was taken of this region of the sky. You might just be able to spot the teapot on the left-hand side of the picture. The very brightest object which is in this picture is not a star, but in fact it's the planet Jupiter. And Jupiter is very roughly in that position in the sky this evening with respect to Sagittarius. That picture that I took, though, was taken 12 years ago. And it just shows that over the course of time, the planets do move around. In 12 years, Jupiter has made a complete circuit around the sky and is now returned to Sagittarius.
That was a short exposure that you had there.
That was only about a 25-second exposure.
What do we get if we make a longer exposure?
Well, so if we take a longer exposure and to save just our cameras on a tripod, then we start getting those star trails that we were mentioning before. Now, if we have a camera, say, that is somehow set up to compensate for the Earth's rotation, and we expose for a long time, then we start to get a lot more stars and a lot more objects. And in fact, in our next slide, we're looking into this region of the sky of Sagittarius, and we're looking towards the center of our Milky Way galaxy. Now, our Milky Way galaxy contains about 400 billion stars, and it contains all kinds of gas clouds and star clusters and all kinds of interesting objects. And the summer Milky Way is a very interesting sight to look at in the sky.
Well, there's certainly thousands of stars in that picture. About how many stars can we see on an average night just with our eyes?
Well, with our eyes alone, of course, if you're in the city of Toronto, you're seeing about 100
Not a
stars,
heck of a lot, right.
150, something like that. If someone is fortunate enough to go up to, say, maybe Algonquin Park, you go out and look up into the sky, you might see there's thousands or millions. Well, really, there's only maybe 3,000 stars or so that you can see with your eyes alone. A very useful device for finding your way around in the sky is a device I have with me. This is what we call a star finder, or it's also known as a planisphere. And this is a device which can be used at any time during the year in order to find bright stars and constellations. There are basically two parts to it. The white area around here is actually a star map, and it shows all the stars and constellations that are visible from Toronto, basically our latitude on the Earth. And this gives different directions, north, south, east, and west. And it's almost like a simple computer. By dialing on a 24-hour clock that is on here, and matching the time of night with the date of the year, in the central oval area, you get the sky that you can actually see tonight. There's a little pin that's sitting in the middle here, or almost in the middle of this oval, and this represents the North Star. And by turning this, you can duplicate the
star trails.
And apparent motion of the stars and the seasonal stars and constellations. Very useful device.
When you talk about seasonal stars, Ian, there is one group of stars which we call the summer triangle. And I believe in our next shot we have a diagram of the summer triangle that we can see, and you can tell us what constellations make that up.
Very high in our southern skies, or high in the southeast, southern sky, we have three very bright stars that form an enormous triangle. These three stars are Deneb, Vega, and Altair. The triangle is so large that if you held your hand at arm's length, the palm of your hand would not be able to cover this enormous triangle of stars. In the next slide, we have a picture that was taken in the constellation of Cygnus, which is one of the constellations associated with this triangle. The Milky Way runs right through the enormous summer triangle, and as a result, if you look at that area of the sky with a telescope, there's lots of interesting things that you can see.
I think if anyone is interested in learning a bit more about the sky, Ian, you have brought in a few books for any aspiring amateur astronomers. Maybe you could just show us.
There's a number of books I can recommend. A very useful book for finding out what's happening in the current sky is a book known as the Observer's Handbook. It's published by the Royal Astronomical Society of Canada on an annual basis. This is the 1984 book, and it contains all kinds of charts and monthly information about when phases of the moon, where the planets are, when meteor showers are occurring. A very useful publication. For beginning sky watchers, a book I highly recommend, one that I started off with many years ago.
I did too, actually.
Is that right?
Yeah.
It's a very popular book. H.A. Ray's book, The Stars, A New Way to Look at Them. And it's very, very good for beginning observers. Another one is written by a very well-known astronomer, amateur astronomer Leslie Peltier, is Guideposts to the Stars. And it's talking about, rather than just using constellations, he uses the 16 or 20 brightest stars in the sky as a means of finding your way around. And then another good book, which has just come out very recently, and it's written by a Torontonian, Terence Dickinson, is this book, Night Watch, which is useful for, got all kinds of nice pictures in it, and a very good description of stars, constellations, planets, meteor showers.
Excellent book for beginning amateur astronomers.
Highly recommended book.
Well, Ian, other things we can look at in the summer sky is meteors. Anyone who's been up in a dark Algonquin Park evening has seen a few shooting stars or meteors. Tell us about them.
This is a very good time of the year to be looking for meteors, particularly late July and into the month of August. Meteors are basically little bits of rock or dust, about the size of your baby fingernail. They're traveling through space very quickly, and when they hit the Earth's atmosphere, they rub against the air molecules, they heat up, and we see them in the sky for a few seconds. We have some pictures that show meteors. So go to our next slide. We have the constellation of the Big Dipper that you can see, and you can see some streaks in there, and those are meteors. This has again been a time exposure, so we've been able to record a number of meteors. The next slide is showing a particularly bright meteor, and this is particularly what we call a Perseid meteor. Again, we see star trails in the background. The spectacular meteor shower that occurs in August is the Perseid meteor shower. It's occurring in the evening of August 12th. The best place to look for meteors, a couple of evenings on either side of the 12th, would be to look towards the northeastern sky after midnight.
Right.
The Perseids are rated at about 50 meteors per hour, so that's about 1 meteor per minute. And ideally, you shouldn't be in a dark sky.
That's right. The darker the sky, the fainter the meteors.
The more you're going to be able to see, the more impressive the sight will be.
Well, the Perseids aren't the only meteor shower visible during the year.
There are about a dozen major showers, and our next slide shows a table of some of the various showers that occur during the year. We have the Leonid meteor showers, the Perseids, the Geminids, the Quadrantids, a number of meteors that can be
And we have a table of these visible in the next slide. If we could get that up, do we know what causes meteor showers?
Meteor showers are associated with old comets. Comets are sort of dirty snowballs that are traveling around the sun, and as these comets travel around the sun, they break up and fall apart, and they leave behind some debris. And basically, when we see a meteor shower, we're passing through a stream of rock and dust left over from an old comet.
Well, these only as you say, they're very small. Do any of these actually reach the ground?
Some of these objects do actually reach the ground. In fact, we have one with us this evening. This is, I brought along a meteorite, and when these objects are in the sky, we call them meteors. When they reach the Earth's surface, they're called a meteorite. And this is an example of a meteorite. It's a special class. It's what's known as a carbonaceous chondrite, and that's kind of a big mouthful, but basically it's not very heavy. And this is a very it's a fragment of a larger chunk of rock that came down to the Earth. This is in particular known as the Allende meteorite, or as part of a larger chunk known as the Allende meteorite. And this came down in Mexico about 15 years ago.
Oh, good. Well, maybe we can get a nice close-up of that in a second. Can they date these, Ian, these meteorites? They find out how old they are, how long
It's
they've been
thought that
around?
meteorites date back to the very beginning of the solar system, and that they perhaps go back perhaps about 4 billion, 4.5 billion years. They're very, very old, and they've been traveling in space for a long time. So they're a very different kind of an object than you know, the rocks that are on the Earth.
What I like about this is the white spots and the dark spots, and it's actually quite heavy, but it looks like it's very, very old.
That's right. If I brought along an iron meteorite, then we'd really have a lot of trouble.
Bigger table.
They're heavy. That table collapses. But
well, meteorites don't last very long, Ian. Are there other things we can see in the sky that take place very quickly?
Yes. Our next slide shows an event that we call an aurora. An aurora is an event caused by a disturbance on the sun. There's a tremendous explosion on the sun, shoots out particles into space. These particles collide with the Earth's magnetic field, and we get the aurora, or the northern lights. These spectacular dancing colored lights can often be seen on summer evenings.
Do we know when they're going to take place?
No, we don't. They're more or less unpredictable unless we have a report of a large flare having occurred on the sun. These aurora can be white in color, green in color, sometimes rarely red. Sometimes they cover the entire sky, sometimes only a small portion of the sky.
The interesting thing about astronomy that intrigues me is the fact that it's always changing. And Ian, you have some magazines tonight.
I've got some magazines I brought with me as well, which give some information on things that occur.
More or less the latest things in astronomy, what's really going on.
What exactly is happening. This is one of the two popular magazines in astronomy, what we call Sky and Telescope, and it contains all kinds of articles and star maps and current events that are happening, things to look for and observing techniques. Another very good book magazine is Astronomy. These are monthly publications. Astronomy calls itself the world's most beautiful astronomy magazine, and has lots of artwork and photographs and amateur pictures, and it's a very useful publication for amateurs. And then another magazine that's also monthly, which is for children, is Odyssey.
And these are available in science stores across the city. And the nice thing about Astronomy and Sky and Telescope is that they both have monthly star charts, too.
That's right, which is very useful to have if you want to, because certainly the stars of December are very different than the stars of August.
That's right. Let's talk about the moon. The moon is always visible. Is there anything we can look at with our naked eye when looking at the moon, see the moon changing or anything?
Certainly we
like
notice that the moon has got light and dark colored markings on it. If we have a pair of binoculars, we start to notice there are craters on the moon, and if we go to using a telescope, then we can see many more things. We can perhaps go along and have a look at some pictures of the moon. Our next slide is going to be showing us a first quarter moon. This is a site probably many people are familiar with, the dark features and the light areas. The next slide is showing us a full moon. Unfortunately, this year the Perseids are taking place at the time of a full moon, and it's going to make it difficult to observe them. Our next slide shows us the last quarter moon, and this is a phase of the moon that many of us are not really familiar with. We're usually not up at that time of night when the last quarter moon is around.
Well, Ian, apart from the moon, this summer is also a very good time of the year to look at the planets. And there are, as you mentioned at the beginning of the show, there are 3 bright planets visible. Could you tell us about them?
3 planets visible. Well, first of all, I'll show a slide of Jupiter. Jupiter is the brightest object in the southern sky for about the next 2 months or so, with the exception of the moon. The brightest star-like object. Jupiter is the largest planet in the solar system, and if we can get our slide up, we can have a look at Jupiter. There we are. If we look at it through a fair-sized telescope, we can perhaps pick out some bands, maybe the great red spot, which is in the upper right part of Jupiter. With a good pair of binoculars or a small telescope, you can see 4 of Jupiter's moons revolving around it. We also have another planet, Mars, and it's in our next slide. Mars is the so-called red planet. It was particularly bright in the sky last May, the brightest it's been in 11 years. But it's gradually fading now, and it's going to be sort of rather insignificant object a few months from now. But during August, it's a very nice sight to see. And then our last slide showing the planets is showing us Saturn.
My favorite.
It's a fantastic object. Saturn with its beautiful rings. I've yet to meet somebody who's looked at Saturn through a telescope and not been impressed. And Saturn is very close to Mars in the sky these evenings.
Although they're a couple 100 million miles in distance apart.
That's right. They're actually a long distance apart in terms of actual distance.
Well, as you mentioned, these planets, they do look like points of light without any optical aid. But once you get tired with just using your naked eye, I guess you can move up into to using some optics.
Many people want to go and get a telescope, first of all, but I usually recommend they get a good pair of binoculars.
Why is that?
I brought along a pair of binoculars with me. The binoculars are, first of all, they're not that expensive. You can get a good pair for, $90, $100. And they're useful for learning the sky, sweeping through star fields, looking for star clusters, seeing good portions of constellations. After a person has become familiar with maybe the basic sky, then they might go towards getting a telescope. Just beside you is a telescope that is known as a refractor. This is a good basic instrument for beginners. I would recommend not paying anything less than about $200, $300 for a telescope.
This is what I'd say is a good starting telescope.
A good starting telescope. It has a lens which is about 2.5 inches in diameter. It's what we call, again, a refractor telescope. And then if a person wants to really getting into the hobby and they want to get a more impressive instrument, they can go ahead and get a telescope like this one. This is a 5-inch telescope.
Meaning the mirror is 5 inch.
The mirror down here is 5 inches in diameter. This gives you much greater light gathering power. You're able to see much fainter objects, and you can really go into looking for galaxies and star clusters and gas clouds in space.
And that's what it's all about. Just the bigger the mirror, the more you can actually see.
Just that greater light gathering power, the greater ability to collect those few photons of light that are coming from these distant objects.
Well, we have a few slides of these deep sky objects. Ian, maybe you could tell us about those.
Yeah, we have a look at them. The first object I wanted to show you is an enormous city of stars in the constellation of Hercules. This object, Hercules, is high in our southern sky, and this star cluster contains about 1 million stars, very, very far away from us, and a popular object in amateur instruments. Our next slide is showing us a nebula, or a gas cloud, and this is in the constellation of the Lyre, and it's what's called the Ring Nebula. And our third slide is showing us a galaxy. And this is the great galaxy in the constellation of Andromeda. Now, it's something which is not visible till much later on in the evening. You have to look after midnight in order to find this. But it's a very impressive object, the most distant object you can see in the sky using your eyes alone.
Actually, you can see the Andromeda Galaxy on a very dark night with your naked eye.
That's right.
It's quite amazing.
Incredible.
Is there anywhere people can go to get a look through telescopes without having to go buy them?
Well, they want to look through a really big telescope. The place to go would be the David Dunlop Observatory in Richmond Hill. It's about 20 kilometers north of Toronto, off Yonge Street, Highway 11. Our next slide is showing us a picture of the David Dunlop Observatory, and it has an enormous telescope with a mirror 74 inches in diameter. You can go up there on a Saturday night, you phone and make a reservation. You phone 884-2112, make a reservation during the weekdays. There's no charge, and they have 2 tours each Saturday evening.
And it should mention that David Dunlop Observatory is run by the University of Toronto, and also they're celebrating their 50th anniversary next year. We're all very excited about that.
1985. It's going to be very exciting.
And the Toronto Centre, they have telescopes set up there Saturday nights too, so we can you can look through smaller telescopes.
Small
at the
telescopes
same
and
time.
big telescopes.
What else can we do, Ian, in summary?
There's a lot of different things that are going on in astronomy in Toronto. Of course, you can visit the planetarium. We have astronomy shows going on at the planetarium. In the Toronto Star on Saturdays, you have Terry Dickinson's astronomy column, which you can read and give you current information. We also have Monday evening programs to find the stars and constellations of the planetarium. And there's also an astronomical hotline at the planetarium that you can call 978-5399, and it gives you information on what's happening in the current sky.
And also, this August 7th, for anyone who's down by Harbourfront, we will be holding, the RSC, Royal Astronomical Society of Canada, will be holding its first annual Star Party on August 7th, if it's clear. That is, if you can see the moon, we'll be holding this starting at dusk and going through until midnight. And we hope to be able to look at the moon, Jupiter, Saturn, and Mars, everything we've been talking about tonight. That's going to be down at the Harbourfront, just south of the York Quay Centre on the Seawalk there. And I suppose, Ian, will have telescopes like the 5-inch
Also a lot of telescopes,
Celestron,
8-inch telescopes,
8-inch
10-inch.
telescopes. And also give you an opportunity to ask any members of the Astronomical Society questions you may have about astronomy. We can only talk about so much in 30 minutes. You know, you want to see we're moving along quickly here to cover everything, because there's really a lot to talk about. But I think the summer sky is really the most beautiful time of year, apart from, well, I guess the weather in southern Ontario can be a bit of a problem in the mosquitoes. But if you ever do
Still a
get
good
up
time
north,
for observing, looking, going outside and looking up at the sky.
right. Well, thanks very much, Ian, for coming by today, telling us about the summer sky.
Thanks so much, Randy.
And I'd like to thank you for watching Astronomy Toronto. Astronomy Toronto is produced by the Toronto Centre of the Royal Astronomical Society of Canada, which is an organization of both amateur and professional astronomers who are getting interested in astronomy, learning more about astronomy. And if you want some more information on joining the Royal Astronomical Society of Canada, our annual dues are $20, and you can become a member by getting in touch with the McLaughlin Planetarium. Right to the RSC, care of the McLaughlin Planetarium, 100 Queen's Park, and we'll be putting up that address at the end of the show. Again, I'd like to remind you that the David Dunlop Observatory is holding public star nights every Saturday night. We're having a star night August 7th at Harbourfront. That is, if you can see the moon that night. If it's raining, then we'll be holding it on August 8th and August 9th. So again, thanks very much for watching. September's show will be on radio astronomy. My name's Randy Attwood. Bye for now.